Dear friends, I welcome to another presentation. In today's presentation, I would like to explain about the differentiation. The differentiation is also called as derivatives, also called as derivatives or derivation. You can call derivation or derivatives. The actual word is differentiation. So normally this differentiation is denoted by d by dx. Suppose, okay, the differentiation as the first letter in the differentiation is d, that is why we use d by dx notation, right? D by dx of something, d by dx of something. So here the something is nothing but any function f, any function f. If any function f is given or any value is given for that given function or for the given value, we can determine or we can obtain the differentiation of that particular function, or we can find out the differentiation of the given value or variable, whatever it is. So here, if I write d by dx is nothing but I am going to apply, I am going to find out the derivative of the function with respect to x, with respect to x, right? So therefore it is a very simple, very simple topic actually. So please follow without any confusion, right? Very simple actually. Say for example, if any function uh, f of x is f of some f is equal to some function is given, f is any function, f is any given function, f is any given function, let us say, okay, then what is the derivative actually? What is the derivative of this? The derivative of f is nothing but d by dx of f. I can write like this. I can write like this. This is the this, if you write like this, d by dx of the function. Function is the given function f. So if you write that d by dx of f, that means that I am going to differentiate, I am going to apply the differentiation to this function with respect to x, given that f must be, this function must be function of x. So f must be function in x, in variable x. So variable x, then only I can able to find out d by dx, right? So that is very simple, and there are certain small formulas need to be remembered that I can write here. Okay, say for example, suppose if you say, if f of x is equal to some x is there, for example, f of x equal to some x is there, find find okay, differentiation, find differentiation find differentiation of f of x, if it is the question. Okay, if if f of x is equal to x, then find differentiation of the function f of x. Nothing but what? Differentiation of f of x is nothing but differentiation of x. Okay, that means that what? How I can solve this? Nothing but differentiation of f of x. So if you say that f of x is the given function, f of x is nothing but what? F is the function in the variable x. F is in terms of x. That is the meaning of it. Or the function f depends on the variable x. That is the meaning of it. If f is written like this, f within the bracket x is nothing but the function f depends on x. Okay, don't confuse. Sometimes this can also be written as f is equal to x also. Don't get any confusion here. So this can also be written as f is equal to x, or otherwise the same f of x is equal to x also. You can write like this also. Nothing but what? F of x is nothing but straight away. Okay, that means that we have to imagine, or we have to, okay, we have to consider that f depends on x. Okay, like this, f of x is equal to x, right? Then how to determine the differentiation? So as I already explained just now, the differentiation can be denoted as d by dx of d by dx of f of x. If you write like this, any confusion in this? No. So if I write d by dx of my f of x, then this means that I am going to find the meaning of this is nothing but I am going to find out the differentiation of the function f of x. Okay, and this implies d by dx of what is the f of x value? F of x is equal to x. Then you write x. Why? F of x is nothing but what? X only. Therefore, in place of f of x, you write x. And this is equal to, if you multiply d multiplied with x, dx. I can write like this, no? Dx by this dx. Clear? So, d by dx multiply with x, nothing but dx. If this, okay, d multiplied with x, dx by dx. Therefore, numerator dx, denominator dx by dx, both are similar, then the value is 1. Okay, then what is the meaning of it? Differentiation of f of x, or f of x is nothing but x. That is what? D by dx of x. D by dx of x is equal to 1. D by dx of dx is equal to 1. This is the answer. Right? Similarly, I will explain you the another simple example. I will explain you another simple example. Okay, let us consider f of x is equal to, let us consider another example. f of x is equal to, let us consider it is something, okay, something, I will f of x is equal to some 5x plus 10x square, like that. Say for example, f of x is equal to 5x plus 10x square is given. Then the differentiation, then then the differentiation, what is that? Differentiation, then the differentiation will be given as, will be obtained as, or will be obtained as how? Obtained as how? It is simply nothing but d by, you see that your f of x is definitely in terms of x only, no? Here 5 into x, 5 is the constant, remember, 5 is the constant, x is the variable here, 10 is the constant, x square is the variable. Otherwise, both this f of x is in terms of x only. It is here x, here it is x square, but in terms of x only, no? Therefore, I can write the differentiation of f of x like this: d by dx of f of x. You can write like this: d by dx of f of x. This means that what? It is nothing but d by dx of, what is my f of x? F of x is nothing but expression is given. It is 5x plus 10 into x square. Are you getting or not? Okay, 5x plus 10 of x square. Then there are two terms, 5x plus 10x square. This is one term plus another term. Therefore, you expand as a two parts. Okay, how I can expand that? That is nothing but simply, you can write simply. So this implies d by dx of, it is 5x plus 10x square, no, 10x square. Then this can be written as, I can write like this now, d by dx of 5x, right? I can write separately, plus you apply this d by dx to the next second term, that is nothing but d by dx of 10x square. I can write like that, nothing wrong in that, 10x square. Get it? And furtherly, the next step will be, remember that this implies, remember that this can be written as 5 is constant. Follow very clearly, 5 is the constant. You can write this 5 to the outside, you can bring that 5 to the outside, then you apply d by dx to the x, nothing but d by dx of x. You keep in the bracket only, you can keep x within the bracket, take this 5 as outside because 5 is a constant, right? Then that can be written as like this, plus here tell me 10 is the constant, therefore 10 you write outside, so you can take 10 outside. It is d by dx of x square, d by dx of x square. Clear? This implies, as just now we did in our just now in our initial example, you can write dx by dx. It is dx by dx plus and 10. Remember that d by dx of x square, d by dx of x square. Remember that there is a formula. There is a formula. You please remember that. You please remember that. I will write that formula here. I will write the formula here. D by, it is d by dx of x power n. If anything is there in this fashion, if anything is there in this fashion, so you can write that if you apply the derivative d by dx of x power n, it is nothing but n into x power n minus 1. That is the formula. This is the formula you should remember. What is the formula? D by dx of x power n is equal to n into n, nothing but this n only, n into x power n minus 1. So here my value is x square. Therefore, if you apply the same here, d by dx of x square, this is equal to, what is n here? This is the general formula. This is the general formula we should remember. So what is n here? If you compare this x square with x power n is equal to 2. Am I correct? N is equal to 2. Therefore, if you substitute the same, this 2 in this formula, 2 into x power, what is n? 2 minus 1. Therefore, how much? It is 2 into x power. 2 minus 1, it is 1. This is equal to 2 into x power 1 is x only. Therefore, d by dx of x square, how much? It is 2x. Therefore, d by dx of x square, directly I can write 2 into x. 2 into x, that's it. According to this formula, I substituted this x square in this formula. I got the value 2x. Therefore, how much? D by dx of x square is nothing but 2x. Therefore, if you further simplify this, as already I explained just now, dx by dx both will cancel out. 1 is the answer here. I mean 5 plus 10 into 2, 20. 20 into x. 20 into x. That is the answer. That is the answer actually. This will be the answer. This will be the answer. Got it? Got it? That is the thing. This is very important, right? This is how the differentiation can be determined. The differentiation can be determined. And simply, as I am going through some of the previous question paper, I came across so many important models. That's why I have decided to give at least some few examples on this for your benefit actually, right? And similarly, there are some trigonometric functions also there. There are certain trigonometric functions, and there are some other functions are logarithmic functions, right? So before going to in that different functions, as I already just mentioned the formula, always remember that it is just now I explained d by dx of, already I explained just now You remember that it is d by dx of x power n. What is the formula? N into x power n minus 1. You have to remember this formula. This is one of the important formula. And then derivative of constant, derivative of some constant, derivative of constant is 0. If you any constant, maybe 10 or 1 or whatever the constant, if you take the derivative of the constant is 0, right? And similarly, and there is one important formula normally, that is d by dx of some important formula will be used in the derivative. Sometimes some two functions will be given in such a way that both will be in the order of multiplication, nothing but it is something u into v. So I can consider them as like this. So two functions, those two functions I will consider as the first function as u, the second function as v, then d by dx of u into v, because some two functions will be given sometimes. If okay, two functions are given, if those two functions are in such a way that both are in the product, okay, in nature, or as both are in the multiplication like this, then if you want to take the derivative of that or differentiation of that, there is a formula actually, it is u into dv plus v into du. That is the formula. So if you expand this, derivative of u into v is equal to u into dv, nothing but what? If you consider it as a first function, this as the second function. You can consider it as the first function, consider v as the second function. If you expand this, that means that first function and derivative of second function, dv nothing but derivative of second function, plus the second function into derivative of first function. Understood? The first function into derivative of second function plus second function v and into derivative of the first function. So this can be easily understood while solving the problem. Don't feel any confusion with this formula. It's a very simple formula. While solving the problem, you will feel very, very easy actually. Just you remember this formula for the time being. And there is another important formula normally. So it is d by dx of u by v. Sometimes some functions will be given. So in the bracket, whatever I am writing, treat it as a function. Nothing but what? U is a function and v is another function, or values, you can say two values or two variables or two functions, you can call anything. If they are in the form of division like this, u by v in the division, then for that function which is there in the division form, for that if you want to apply the derivative, then how the derivative will become very easy. So if something is there in this format or in this form, then the differentiation of that form will be like this. If u by v, so this is first function, this is the second function, or the numerator or the denominator, then that can be expanded like this: v into du minus u into dv by v square. That is the formula. Very, very important formula. Very, very important formula. If any function, two functions are given, and if they are in this form, for that if you want to take the derivation or differentiation, you should use this formula: v, nothing but the derivative function, into du, derivative of the numerator. So the denominator into derivative of the numerator minus numerator into derivative of the denominator by the square of the denominator. Very, very important. Very, very important. Right? This is the another important formula that we have to see actually, that we have to remember. Right? And okay. And similarly, there are certain important things to remember. There are certain trigonometric functions also there. So some trigonometric functions, trigono, trigonometric functions. So these are what the normal functions actually. That is, f of x is in terms of some x, and then like that. Whatever the simple example just we have seen. Sometimes other than that, sometimes the function will be given in terms of the trigonometric function also. Like what actually? F of x is equal to, what are the trigonometric? There are various trigonometric ratios are there. Those are like sin theta, okay, and f of x is equal to cos theta. These are the trigonometric functions: sin theta, cos theta, tan theta, and cot theta, secant theta, and cosecant theta. These are the various trigonometric functions are there, and sometimes the function will be given in terms of the trigonometric functions, and for that you will be asked to find out the differentiation of these trigonometric functions. At least you should remember at least a few of them, at least. Okay, so for your benefit, I just explain you the small important things which will be very useful for your examinations. Say for example, if sin theta is given, if sin theta is given, if sin theta is given, okay, then the differentiation, then, okay, or sin x you can call, or sin theta or sin x, whatever you can call. So some d by dx of sin theta is equal to, because as it is the theta, then you can write actually d by d theta, or if sin x is there, you can write theta or x, nothing wrong in that. Here x or theta shows the angle, nothing to worry about much about this. Okay, sin x. X is the angle actually. You can write either x or theta, whatever it is. Sin x. If sin x is given, then d by dx of sin x is nothing but derivative of sin x is equal to cos x. That is the formula. So derivative of sin x is equal to cos x. Similarly, if it is cos x is given, if cos x is given, then d by dx of cos x, d by dx of cos x is equal to, minus sin x. Please remember. So d by dx of sin x is equal to, what is the answer? Cos x. D by dx of sin x is equal to cos x, and d by dx of cos x is equal to minus sin x, and similarly d by dx of tan x, d by dx of the third function, trigonometric function, is tan x. What is the d by dx of tan x? Can you anybody, can you answer me? What is the d by dx of tan x? So to find out the d by dx of tan x, first you should know what is tan x first. What is tan x first? How to define the tan x? If you know the definition of the tan x, then you apply the derivative of this, right? So I will explain you this. D by dx, d by, okay, what is the derivative of tan x? D by dx of tan x, I am asking. Tan x. So if you know the sin x and cos x, just now I just explained you about the sin x, and then the second one is the cos x. Trigonometric is also another important chapter. Soon I am going to explain you about that also. Don't worry about it. So okay. So there are some certain trigonometric functions will be there: sin x, cos x, and after that third one is the tan x, and then cot x, and then secant x, and then the first last one is cosecant x. How many are there? 1, 2, 3, 4, 5, 6. These are there are 6 functions will be there. These are called as the trigonometric functions: sin x, cos x, tan x, cot x, secant x, and cosecant x. And I will explain you in detail about the definitions of all these while discussing about that trigonometric chapter. And for the time being, just you remember whatever I am discussing now. Okay, if you know the sin x as well as the cos x, if you know these two, we can make wonders or magics with these two. Remaining all these 4 functions will be defined. If you know these two, the rest of four will be automatically defined by using these two. How? Tan x is nothing but sin x by cos x. That's it. What is that? Tan x is equal to, if you take sin x by cos x, that is the definition of tan x. Tan x is equal to sin x by cos x. If you know the value of sin x and if you know the value of cos x, do sin x by cos x, that gives the tan x. How is it is? See, tan x is equal to sin x by cos x. And similarly, what is cot x? I will explain here itself. What is cot x? Cot x is nothing but just reverse this value. You take the reverse, nothing but what? Cos x by sin x. Cos x by sin x. Don't mistake. Don't feel any difficulty to remember this, right? So tan x is nothing but sin by cos, and cot will come by taking the reverse, I mean cos x by sin x. If you take cos x by sin x, you can get the value of cot x. Understood? And similarly, what is the secant x and the cosecant x? How you will get secant x and the cosecant x? Secant x, you will get the secant x value. You will get the secant x value. It is something 1 by cos x. If you take, the cos x, then take 1 by cos x, then you will get secant value, secant x. And similarly, the final cosecant x. Cosecant x is equal to 1 by sin x. I think you got all the definitions, no? Cosecant x is the last one. How you will get? 1 by sin x. You know the sin x value. Take 1 by sin x, then you will get cosecant x. Understood? See how easy it is? If you know these two, the remaining all four will be defined in terms of sin x and cos x. Okay, therefore what is the tan x? Sin by cos. What is cot? Cos by sin. What is the secant? 1 by cos. What is cosecant? 1 by sin. That's it. That's it. Okay, okay, fine, very fine. Then what is the value of this d by dx of tan x? Can anybody? Can anybody? So what is the d by dx of tan x? Very simple. Follow me very clearly. So d by dx. What is tan x actually? It is sin x by, just now I told you, no, it is sin x by cos x. Am I correct? Sin x by cos x. Am I correct or not? Then what is this form? What is this form? It is u by v form, no? It is something u by v form, no? It is u, it is v. What I told just now? What I told just now? D by dx of sin x by cos x. It is something in the form of u by v. This is u, this is v. What is the formula I just now told? Have you remembered it? V into du. I am writing again. As I write repeatedly, you can remember it very effectively. Okay. So v du minus u into dv by v square. This is the normal formula, general formula you have to. So in this formula, you substitute these values. V nothing but cos x. Cos x is v, sin x is equal to u. This is u, this is v. Substitute these values in this formula. What you will get, what is v? V nothing but cos x, it is cos x. What is du? Du nothing but derivation of u. What is u? Sin x. Derivation of sin x, nothing but what? D by dx of sin x. That is the meaning of it. D by dx of sin x. Are you getting or not? D by dx of du nothing but, in short, not required to write d by dx. You can simply write d also. D stands for d by dx. This d stands for d by dx. Therefore, d by dx of u, like this, minus, what is u? U nothing but sin x. It is sin x. What is dv? Differentiation of v. What is v? Cos x. Nothing but what? D by dx of v. What is v? Cos x. Cos x. Whole by v square. Whole by. What is this? Whole by. Whole by. What is v? V is the cos. Nothing but what? Cos x square. Cos x square. Simplify that. Simplify this particular. So I am erasing this, and I think I will stop with this also. That I will continue in the subsequent after finishing this. Okay. Therefore, this is what? D by dx of tan x I am solving for. D by dx of tan x I am solving. This is equal to what I written here. D by dx of what is tan x? Sin x by cos x. Sin x by cos x, and this is equal to this actually. And if you substitute, if you simplify this particular, what is the cos x? What is the cos x? Is cos x only, right? D by dx of sin x. D by dx of sin x. How much? Just now I told you, no? D by dx of sin x is nothing but how much? It is cos x. Understood? D by dx of sin x is equal to cos x. Remember, minus sin x, right? Sin x as it is. Sin x as it is. D by dx of cos x, how much? D by dx of cos x is equal to minus sin x. Remember that, minus sin x. Minus sin x by what? It is cos x square, nothing but cos square x. You can write like that also. Cos square x. Cos x square, nothing but cos square x. Cos square x. You can write like that also, right? Then how I can write? Then what is the final simplification? And this is equal to cos x into cos x. I can write cos square x. Am I clear? Cos x into cos x, cos square x. That can be written like this. Minus here into minus, minus into minus, plus. Sin x into sin x, sin square x. Getting or not? Sin x into sin x here, this minus into minus plus sin x into sin x, sin square x by cos square x. Cos square x. This is equal to, there is one important formula in trigonometry. Cos square x plus sin square x is equal to 1. The formula is 1. 1 by, it is cos square x. It is cos square x. I just now I told you that 1 by cos is what? 1 by cos is nothing but secant. Just now I told you, no? The definition of secant. What is secant? 1 by cos. 1 by cos is equal to secant. If you refer your notebook, just go back. 2 minutes back I have already explained you that. Secant. How you can get secant? 1 by cos. If you know the cos value, if you take 1 by cos, you can get secant. Therefore it is 1 by cos, nothing but secant. Therefore 1 by cos square, nothing but cos square is secant square. Therefore it is secant square x. That is the answer. Sorry. Therefore d by dx of tan x is equal to secant square x. That is my answer. Therefore d by dx of tan x is equal to secant square x. That is my answer. This is my answer. Remember this. I hope you are getting well and you are understanding well. And with this, I will finish off this presentation because just I wanted to explain this. Okay. And in subsequent presentations, we will see more number of questions on these topics. Right? Thank you. Thank you very much.